Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating paper revealing how large language models, or LLMs, actually perform addition. It's not what you might expect.
Ooh, I'm intrigued. I always assumed it was some sort of complex hidden process. What's the secret sauce?
The secret, it turns out, is Fourier features. The paper, Pre-trained large language models use Fourier features to compute addition, shows that LLMs represent numbers using these features, which are sparse in the frequency domain. It's like a hidden mathematical code within the model.
Sparse in the frequency domain? Could you explain that a bit more? I'm not a signal processing expert, you know?
Sure. Think of it like this. Instead of representing a number directly, the LLM uses a bunch of different frequencies, kind of like musical notes. Only a few of these frequencies are turned on for any given number, making the representation efficient. High frequencies capture fine details, while low frequencies represent the overall magnitude.
I see. So how do the different parts of the LLM use these Fourier features?
That's where it gets really interesting. The MLP layers, which are essentially the model's number-crunching engines, mostly use the low-frequency features to approximate the magnitude of the sum. Think of it as getting a rough estimate of the answer.
Got it. And the attention layers?
The attention layers, which are more about relationships between different parts of the input, focus on the high-frequency features. They're essentially figuring out the finer details, like whether the sum is even or odd, a kind of modular arithmetic.
That's a really elegant division of labor. But what about pre-training? The paper mentions that's crucial.
Absolutely. The key finding is that pre-training is essential for this Fourier feature mechanism to work effectively. Models trained from scratch to add numbers only use the low-frequency features, resulting in much lower accuracy. It's like they're missing the fine-grained details.
So pre-training somehow teaches the model to use these high-frequency features for modular arithmetic? That's a pretty significant finding. It suggests that the way these models are trained fundamentally shapes their ability to perform even basic arithmetic.
Exactly. Adding pre-trained token embeddings to a randomly initialized model dramatically improves performance, proving that the right kind of pre-trained representations are key. It's a testament to the power of pre-training in unlocking complex capabilities within these transformer networks.
This is fascinating. It really changes how I think about the inner workings of LLMs. It's not just some black box. There's a surprisingly sophisticated mathematical structure underlying their ability to perform even simple tasks like addition.
Precisely. The paper highlights that appropriate pre-trained representations, like these Fourier features, can unlock the ability of transformers to learn precise mechanisms for algorithmic tasks. It opens up exciting avenues for future research into how these models learn and reason.
Definitely. This research sheds light on the surprisingly intricate mechanisms behind seemingly simple operations in LLMs. It's a great example of how deep learning can lead to unexpected discoveries about computation itself.
Absolutely. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the fascinating world of LLMs and Fourier features. Until next time, goodbye.
Bye-bye.